Welcome back, Pre-Calc. Hope y'all are well. Our objective today is going to be to do some more graphical limits, but this time you're going to need to produce the graph yourself. So we're going to graph and find limits of piecewise functions. I've got the checklist on the screen. You know what to do from here. All right, so I'm actually going to do one off your homework. This is going to be question 4. We're going to do it together. So I'm going to force pause on your screen. Either go grab that worksheet, or if you can, print it off, or upload it to a tablet. That's a possibility. Otherwise, grab some graph paper if you've got that, and we are going to do question 4 together. All right, so a little bit of a review of graphing piecewise functions. What I really recommend is starting off with a table, okay? And then let's take a look at our two pieces. So our top piece is valid for x is less than 2, and our bottom piece is valid for x is greater than or equal to 2. Okay, so what I'm going to do is I'm going to take this top piece and graph it in red, and then the bottom piece I'm going to graph in blue. And I'm going to create the table based off these functions, and then I can plot my values, okay? Now, here's something I want you to be very mindful of. We are, yes, going to use values less than 2 for this top piece, for the red piece. However, what I see is then students often avoid 2. And we don't want to do that because then you will miss all the values between, say, x equals 1 and x equals 2. So what you're going to do is go ahead and include 2, but would this top piece be an open circle or closed circle at x equals 2? The top piece is going to be an open circle, and the bottom piece will be open or closed. The bottom piece will be closed because it's greater than or equal to. All right, so let's take a look at that top piece. I know that I want to use x is less than 2, and what type of function is the top piece? The top piece is linear, so I really only need 2 points to graph a line, right? Because then I can just connect them. So let's pick a nice value that's less than 2. How about x equals 0? And then I also want to make sure I include x equals 2, and I'm just going to make a note for myself that I do want an open circle at x equals 2. All right, so let's plug these values into the top piece. When x is 0, what does the top piece become? The top piece becomes 0 plus 1, which is 1. When I plug in 2 for x to the red part, what does the top piece become? The top piece becomes 1 plus 1, which is 2, right? All right, let's move over to the blue piece, the bottom piece now. So I want to pick back up at 2, this time using a closed circle, and then I want to use x is greater than 2, and I do try to think ahead, like what's going to give me a nice output. So I'm thinking that maybe I want like the square root of 9, right? So 9 inside the radical, so possibly 4.5 would be a good input, okay? So when I plug in 2 for x, I get square root of 4, which is 2. When I plug 4.5 in for x, I get square root of 9, which is 3. All right, so let's plot these points being very mindful of our open and closed circles. So the red piece is a line. It has the point 0, 1, so here. And then also the point 2, 2, but with an open circle there. And remember, this was valid for all x's less than 2, so we're going to connect these dots sort of like this, and that will be the left part. So this would extend to the left forever. All right, now let's look at the bottom piece, the blue piece. So I'm going to have a closed circle now at 2, 2. And notice that this closes it in. And then I also have the point 4.5, comma 3, and we know that this is a square root function, so it's going to grow, and it's going to have a curvature too. It's going to be concave down, but it's going to grow very slowly, okay? All right, so now let's take a look at our function here. The top piece is valid for all x's less than 2. So for x's less than 2, would that be your right limit, your left limit, your full limit, or your function value? This would be my left limit because it's x is less than 2. For x is greater than 2, that would be which limit? Your right limit. Okay, and then this equal sign would also be your function value. Now, notice that if I plug 2 in for both the top and the bottom, I get 2 out for y in both cases, right? So this is nice and continuous because the left limit, the right limit, and the function value are all the same thing. They're all 2. So in this case, all the limits are 2, And the function value is also 2, making this a continuous function at x equals 2. All right. Now, if we had kind of a jump there, let's pretend our function looked like this instead. So this time, what is our left-hand limit? Our left-hand limit is still 2. What about our right-hand limit? Our right-hand limit is 3. What's our full limit? Our full limit doesn't exist because our left and our right are different, correct? It has nothing to do with that closed circle. What does the closed circle represent? The closed circle represents your function value, so that means that f of 2 is 3. All right? Okay, so go ahead for your assignment. You're going to graph the other 7 and then answer the limit questions at the bottom of each one. All right, you all, I'll see you next time.